All right, so first off, I just want to thank everyone for joining here and attending this meeting. It's really good to have a lot of the GIS community join in and talk to each other. And I'd also like to give a really special thanks to Dave and Safe for not only helping us put this on, but actively participating and engaging with us in the community. So before we get started here, I just want to give a few quick reminders. We are always looking for suggestions for topics that would benefit you guys in the community. So if you have any suggestions, please let us know. That can be in the chat or via email. My email will be up here on the last slide. And I think a lot of you probably know some other people in this chat, either Eric Abrams or Bo Glow or myself. So you can also just reach out to any of us. Number two, if you're interested in presenting, no matter how complex or basic your topic is, go ahead and reach out to us. We would love to hear from you. And, we have a lot of different skill levels in the community. Some people are experts, some people are beginners, and it's nice to have workflows and presentations that kind of cater to both sides of that coin there. And lastly, if you have any feedback for any areas of improvement related to this FME SIG at all, as always, let us know. Anything we can do to make this better for everyone is beneficial. So today's agenda, we're going to go ahead and talk a little bit about this group background and purpose for about a minute and a half. I'll introduce Dave. He'll give his presentation. We'll have a quick question and answer session and then a wrap up. So in terms of our background and purpose, this FME and Transportation Special Interest Group was created with the purpose of curating and sharing success stories as well as best practices in applying Safe Software's feature manipulation engine, or FME, to the transportation sector. The creation of this SIG was coordinated with the assistance of Safe Software and is meant to be vendor neutral. The Special Interest Group was also created in the hopes of unifying local governments and state level DOTs, as well as the private industry, and kind of serve as a holistic framework for the open sharing of knowledge and active engagement of the community. And that's mostly done through these monthly presentations, but also just through posts and question and answers within the group itself on LinkedIn. And these presentations are meant to demonstrate and elaborate on real world applications and success stories using FME. And outside of the presentations, again, we hope this LinkedIn group can serve as a central repository for these kind of questions and community engagement. Thankfully, we have a product expert here himself to talk to us about all of the cool things about this software. So today we have Dave Campanas from Safe. He's going to be giving his presentation titled How FME Measures Up. And Dave is an FME user since 1997, and he's an applications expert at Safe Software, and he's responsible for assisting strategic clients and partners in their use of FME. And before joining Safe 16 years ago, Dave worked as a GIS manager for an aerial mapping firm. Dave's favorite transformer is the Topology Builder, which I hope he'll talk to us a little bit about. His least favorite food is pickles. And today he's going to be giving us an inside look at how he leverages FME to examine and manipulate LRS geometry within FME, as well as some methods to convert from and to GIS geometries given measurements in an LRS system. And with that, I'm going to go ahead and quit sharing, and I'm going to let Dave take over and do his presentation.
Okay. So share. Okay, screen sharing, good. So everyone can see FME Workbench on their screen, hopefully.
Yes, I see it. Thank you, Dave.
Okay, great, thank you. Okay, today, fortunately, sorry, no Topology Builder today, but I'm going to cover some of the transformers that are quite useful in working with LRS. Also, in order to just sort of let us get sort of down into the weeds of what we can work with, I'm actually not going to use real world data. I've just got some sort of simple contrived data here, but it just simplifies it and sort of helps us understand a little bit better without the distractions of some of the real world stuff going on. And it just simplifies and allows me to show off, the capabilities of FME and in a sort of a simplified manner. So the first thing, I'm creating this data set here. Oh, I suppose I'm not sure how familiar everyone is with FME, but this is, I'm going to be working in Workbench today. We also have the visual preview in Workbench. This is kind of like a version of the data inspector built into Workbench. And that's what I'm going to be working with today, just to keep everything on the same screen, make it a bit easier. To introduce you to the data inspector and the visual preview and what sort of stuff we can view about the data we're working with, I'm just going to click on one of the outputs here. And this is the other thing I'm using today is called feature caching. And what feature caching allows us to do is it creates a copy of the data at each step of the process. And then we can just simply click on a transformer and see what the data in the bottom here, what the data is like at that step of the process. And it makes things a little faster for prototyping your workspace, and also for demoing stuff like this. You can click individually on a transformer, or if you want, you can click on, say, one transformer and then command or shift click, depending, or command or control click, depending on if you're on a Mac or a PC. Click on another transformer, and then you'll see both pieces of data are available here. We have a graphical representation, we have the schema representation, and then I've also turned on the feature information window, because that gives us a deep dive into the features themselves. So to get more into that deep dive, I'm just going to click on this transformer here after we've done a little work. And there's information on the feature here. I mean, this feature information window is really, that's the key thing I use when I'm looking at the data. And it shows you the attributes of the data here. It shows you the geometry. But the other cool thing is you can see on the geometry is these things called geometry traits. And we're going to be using those quite a bit. And geometry traits are basically attributes that have been moved down onto the geometry. And the cool thing about then is if you like combine geometries or separate geometries, the individual parts of the geometry keep their attributes. And so you're not just stuck when this one bin up here. You can have several bins down on the geometry to keep different sets of attributes, and it can be quite handy. The other thing we have is, I'm just going to click on here. We also show the measures in the feature information window. So you can see on each segment here, we have the coordinate, and after the x, y of the coordinate, we have these numbers in the brackets. These are the measure values. And in FME, we can have multiple measures and we can have named measures. Now, basically all measures are named. It's just one of the names can be blank, and we consider that the default measures. And if you come in from shape, or you come in from another format that has measures, but the measures don't have names, they will come in as the default measure. And there can only be one default measure. But if you name your measures, you can have, quite frankly, as many as you want. So that's a basic overview of sort of what we can see of the data. Now I'm just going to run through the workspace and show you how we solve just a couple of problems with the transformers that can work with the LRS data. So I've created the sample lines here. The first thing, and I've created attributes on them, just a simple one, speed limit and a number of lanes on each of these segments. They have a different speed and a different number of lanes, 84, etc. The first thing we want to do is take those attributes, and this is the geometry property setter. And this is basically what takes those attributes from the header of the feature and moves them down onto the geometry. So we call attributes on the geometry in FME lingo is called the trait, a geometry trait. So we're taking this and we're setting the traits on the geometry from the attributes. So we're taking number of lanes, speed, and what the heck, we'll throw in color as well, just because we want to keep track of that. So if we look at the data here, we have these, the simple road lines, and they have a speed, number of lanes, route ID, and color on them. And those are here in the attributes. After we do the geometry property setter, we again still have the three segments, but with the exception of route ID, FME color, number of lanes, and speed has been moved down onto the geometry. And there's an important reason we're going to do that, because in the next step, we're going to combine those three segments into a single line. So in this case, we are combining based on the root ID. So all of these three segments have the same root ID. We're going to say, make these all a single line on that root ID. But what we also are going to do is we are going to preserve the lines as path segments. So instead of a single simple line, we are going to create like a multi-part line with each segment being a separate geometry. So if we look at that output and we look here, we can now have a single line. I'm just going to open this up a bit to show you in more detail. If we look at the geometry, we see that each line or each segment is still a separate piece within this path geometry. And more importantly, each segment still has on the geometry its unique attribute values. So this is a way of combining this line while still maintaining the segmented attribute structure. Okay, and then the next step is, now that we have this singular line, I'm going to generate some measures on it, and this is so we can sort of do LRS manipulations. And if you already have measures on it, that's fine. But in this case, I don't. So I'm going to create two sets of measures. This data, I'm assuming it's in meters. So I'm going to first set of measures is going to be mileposts. So I tell FME in the measure generator to generate measures based on the distance along the line. And we have a multiplier in here, and I want miles, so I'm going to set the multiplier up. So the measures will be in miles, and I can also set a start value. And we can also do 3D or 2D dimensions. I'm going to stick with 2D today. And then, oh, and the second part is here, the destination measure name is, I've just given it miles. It's possible actually to generate this measure name off of an existing attribute on the feature. The interface isn't quite there yet, but there's a workaround that we can do just by using the at value call and then the attribute name. That's handy in some cases. If you have, say you want to put a measures on the features as named after the root ID or named after something. So you can name your measures because you want your measures to sort of be unique and you don't want them to collide with each other. The second measure generator, we're going to generate just a kilometer measures on here as well. And next step is we're going to split this back into paths. And now the reason I joined them together is I wanted to measure that took out the entire route from the very beginning of the route to the very end of the route to generate these measures. Now that I have these measures, I can split the path back into its component segments again. And we'll see that the component segments have retained those measures. If we look here, let's give this a little bit more room. So we have the two measures, the miles and kilometers, each segment. So we take this metal segment, we have its beginning measure and its end measure. So now we've generated measures over the entire route, but each segments, now that they're broken up again, have the individual measures in their place along that route. And the last step we do, just sort of prep the data. We'll take the geometry property extractor, and what this does is it takes those traits that we stuck down on the geometry and it brings them back up as attributes, because in FME, there's a lot more tools that can work with attributes that can work with traits. So attributes are kind of a handier place to have them. So we sort of stuffed them down in traits so we could preserve them while we were doing the geometry manipulation. Now we've brought them back and putting them back on the attributes again. And as we see, their colors have been restored because FME color was one of the attributes we brought up. But they are now properly attributes again. They're still on the geometry as well as traits because I didn't put in a remover, but we could all, if that was going to be a problem, we could remove them instead. So now we sort of prepped our root data to be useful. What can we do with this? Well, now that we have the measures, we can actually create sort of an LRS table out of that root. We have a measure extractor here. And the measure extractor, in this case, we're just going to grab measures by individual vertex to get the beginning and the end measure. But if we want, we could also grab the whole line. And that will return a list of measures as an attribute. You can also pick the source measure name. Actually, you have to pick the source measure name because it only does one at a time. So you can choose the name as a text editor, or if you leave it blank, it will take the default measures on the feature. So here we just extract the begin measure, we extract the end measure. Then because we're going to a table, and I just blow away the geometry and clean up the extra attributes. And so what we are left with, you see down here, is a simple table of the root ID, and then we have a beginning and end measures, and then we sort of the breakouts of the speed and the number of lanes. So it just creates that sort of LRS table from the root data. Another thing we can do is, in this case, we have the root, and we also have a GIS point along that route. And what we want to do is to get the measure of this particular point, the LRS coordinate of that point. So the tool we can use to do this is it's the point on line overlayer. And what this does is it takes that point, it takes the root lines in, and it sort of matches them together, and it finds within a tolerance. So I've given it a 100-meter tolerance, what the information from that line is for that point. And that also includes, you have this option of merge measures here. So it's going to merge the measures from the line onto the point, as well as the attributes. So if we look at the point output of this, we'll see that we have our geometry point. We look at the information in the feature information window. That point has got the number of lanes and the route ID and the speed off of the line that it's closest to, but it's also got the measure location of the closest point on that line to the point. So now we can extract those measures through the measure extractor. And again, we have a table of our event now has a mile post and a kilometer post of that event, the GIS event now suitable for LRS. And we can also do the reverse. So we have here, I've just made a simple event and accidentally given it a mile post and a route ID. And what we want to do then is tie that to the route and find out where the GIS location of that is. So here we've got, and this is another thing, it's handy within your workspace. If your workspace gets complicated and you don't want the lines going all over the place because it's confusing, you can actually hide a connection. It puts these little junctions here and here, and it's just a way of keeping your workspace a little cleaner. So we've brought the route information again. We brought in the event information, and here we're going to use a feature merger. And what we're going to do is we're going to merge on the route ID. So we're going to take that route information, and we're going to merge all of the geometry from the route onto that event. So we're going to take the entire line, we're going to merge it onto that event. So if we click on this and merged, yeah, we've got the route. But the next point is we want to take that route and only extract just the point at that milepost. So we use a transformer called the snipper. And the snipper basically snips the line. And we can snip by distance, percentage, measures, value, and also vertex. And in this case, we're going to snip by measure. So, and in this case, we just have a point, so we just make the starting location and end location the same value. If you have a linear event, you can use the starting milepost and the ending milepost, and you'll get a line out instead. Again, we pick the measure name if we have multiple measures, and we go OK. And the result of that is a point, which is not showing up. The visualizer has a problem if there's only just one point and scaling it out. But now we have a point if we look at the information on here. So it has all the information coming in from the event, but we also have the FME point location for that measure. So that's the sort of basic tools you can use. There are some other tools. When it comes down to working with measures, anything that manipulate, or most, I should say not anything, but most transformers that manipulate the geometry in a certain way are measure aware. So if we use the snipper, if you clip lines by a boundary and measures on the lines, the measures will be properly clipped as well, and the new measures at the endpoints will be properly interpolated from the measures from the original line. So I think that's the basics of what I wanted to cover today. I guess we can open up to questions now.
Hey, Dave, I actually do have a quick question here. I see that milepost is at 138.5, but it's picking up a measure of 100.385. What's the cause for that there?
That's a good question. That's 100 or 161. And it should be starting location is milepost. Yeah, I'm sorry, I missed that before. I'll have to dive into that and figure out what's going on.
Okay.
Yeah, good catch.
Aside from that, I think you brought up one really important thing that I would like you to expand on, that I know that me and Bo encountered, as well as I think I saw Adam Tyra on this call. And that's specifically relating to whenever a point geometry falls on the intersection of two routes and only returns one default measure unless the measures had been named before. Could you maybe expand a little bit on that and talk about why that's the case, or how to mitigate that?
Yeah. Okay. Why that's the case is that measures are part of the geometry, so they are essentially just another coordinate on the geometry. So our geometry is essentially multidimensional, with each measure being another dimension. But because it's part of the geometry, in some cases, if we're joining multiple, or we're overlaying multiple features on a single feature, there's an opportunity for attributes to create a list if it's going to have multiple overlaps. But because that measures are part of the geometry, it's not possible to have a list in this structure down here. But what you can do is, if you have multiple named measures on your data, then we can say, oh, we have multiple measures. We have a miles and we have a kilometers, or we have a route this measure, route A measure, we have a route B measure. Now this takes some preparation, and currently, and both brought this up a couple of days ago, and our dev team is now at work with some enhancements I asked for. We don't have a good way of renaming measures, because ultimately what you'd want to do is say, have your miles measure, let's rename it to its route ID. And then if we have, each route has its own ID, we have multiple measures. And so let me just see if I can illustrate this a bit here. In this example, I'm putting different measures, two measures on the same feature. But if I do this and do that, we will get a measure. We will get two copies of the lines with a different named measure on each copy. So let's just run this quickly. Yeah, and it doesn't like that. Okay. Let's see if we can get this to work. Okay. So output of the path splitter, if we look at that, we have here, instead of one segment, we have two segments. And if we look at the segments, we'll see that, one has the miles, and the other one has the kilometers. And if we look at the overlay here, and we look at the output, we'll see that this one has both the kilometers and the miles. So it's grabbing the measures, it's grabbing the measure from one of the overlaps and the measure from the other overlap, and as long as their names don't intersect, it will grab both of them because it can stack them side by side, and it's happy. So the trick then would be to have your measures with a different name. Now, a lot of times from your input data, you don't have the measures in a different name, and that's where you would use, basically, like I said, right now we're working on a renamer, but in the meantime, you can use a measure extractor to extract the measures to, in this case, you'd grab whole line, and you'd extract them to a measures list, and then you'd use a measure setter. So let's see if we do this. Okay, we do that. We set this to a list, a line, list measures, okay. And this one, we have whole line. We have our measures list. Now this destination measure name, this is where we use that at value. Again, there's another enhancement for this. And we would use the okay, let's enable that. Okay, actually, let's just grab the default measure or any of the, oh, let's use miles. Okay, let's handle that. So we look at this output here. Our measures have been renamed to 0. So we have a measures renamed to 0, as well as the original miles. So we're not actually deleting the measures. We're just creating a copy of the measures with the name 0. And this is the root ID. So each of the roots would have the copy of the measures with that root ID on them. Then what you can do is extract those measures afterwards with a measure extractor, give it the name of the root you're interested in, because in the overlaps, you'd also have a list of the roots that overlap you. So you can take that list and extract the measures for each of the values in that list using the measure extractor and this at value method I mentioned down here. And again, we're updating the transformers to make that a little easier to do. It's not quite so hacked as I'm doing it here. Does that answer the question sufficiently?
Yeah, I believe so. I think the end goal, to kind of sum it up, is whenever you have a point event coming to the point online overlay, and that point intersects multiple lines, the only way to properly pick up the measure is to pre-name the measures. That way you can identify them based on the name. That way it picks up a list of the measures rather than just the last measure it finds, correct?
Yeah, exactly. And like I said, this actually the first time it came up was a couple of days ago. So like I said, it has identified some deficiencies in our interface that we're going to fix to make it easier to deal with that. And I mean, chances are I might just wrap a custom transformer about it and throw it in Hub just to make it even simpler. But I mean, we can do it. We make you work a little harder at it, for which I apologize. But it is kind of based on the structure of the way we store these measures.
Would you also be able to sort of almost doing the same thing, but extracting the measures with the geometry property extractor as an attribute, and then doing a straight attribute comparison based on the two?
No, the geometry properties extractor wouldn't extract the measures because, and again, we try to be fairly granular with our transformers. So the measure setter is working with the measures which are part of the geometry. So they're part of this section here. Mm-hmm. Whereas the geometry properties are essentially this section here. So the different transformers are designed to work with the different parts of the geometry, and they work in different ways. Simply because measures are essentially, except for point, a multi-value piece of data, whereas these are generally single value pieces of data. So the way you work with the data is quite different, which is why we've brought in the separate transformers.
That's great clarification. Thanks.
Sure. But again, if you guys have anything you see that we're not doing and you'd love us to do, we would love to hear from you as well, because you know, most of our transformers are created by customer requests. You guys know your data much better than we do, and you know what you want to do with it much better than we do. So we're trying to follow our customers' leads on when it comes to capabilities and what people want to do with the data. So don't be a stranger.
That's a great point, Dave. In fact, the issue of reverse geocoding one point on concurrent routes came about simply because Indiana DOT's Adam Tyra, when he was using the FME hub version of LRS reverse geocode that we curated, he found that issue. Then we're chasing all the rabbit hole, end up having to come up to you to provide us a solution. It shows the flexibility and depth of FME in a sense, but also I think by this communication help us improve FME going forward. I noticed a couple of years back, quite a few transformers were not measure aware, but I'm glad seeing more and more are being automatically handled as additional dimensions. That's just excellent. Yeah. One other observation I noticed, this is the first time I realized that you can actually name measures. You can have concurrent multiple measures as simply another dimension, name the dimensions, in addition to traditionally we only know X, Y, M, Z, but now you can have multiple of them. It's great flexibility. But I do have a question because none of the other, majority of the other spatial engines that handles LRS assumes one and only one measure. So in this case, you have multiple named measures. When you export, let's say to shapefile, to file-based geodatabase, the two of the most predominant format in the GIS landscape, and which one is being picked up? If there's no default one, they're all named. In this case, you have the miles and maybe the first one being picked up.
I think it might have to be the default, but I'm not sure. I would need to. I'll do a test, and I can get back to you on that. And but that is a good question. Yeah, which one goes out? I think the reason we probably have multiple name measures is there was probably one format out there that had multiple measures on it, and we had to essentially deal with that. I think that's normally the way things like this happen. When you're supporting 400 odd formats, we kind of have to make a superset of all of them, right? So that's probably why the name measures came into being. That or geometry guy thought it was a good idea, but like I showed you, it can be quite helpful, and it can make things a little bit more flexible for working with the measure data within FME. But I'll check on that shape, and I'll get back to you, Bo, if you want to forward that to the rest of the crew and to let you know what happens.
Excellent.
The other thing I've requested, and now that I've been looking at this again, is, and again, I don't know how long it'll take, but it would be really handy to be able to do measure math, run expressions on measures. So and the capability is kind of there within FME, and we could do it now by extracting the measures and exploding the list, doing the manipulation, and then putting it all back together again. And once you've done that process, I don't think it would be particularly performance degrading, but it still would be nice to have something like the expression evaluator, where you can just say, oh, add 50 to all our measures or scale our measures. We want it, somebody gave us measures in kilometers. What's with those crazy Canadians? Let's put it in miles, right? And so you could just scale all your measures if you wanted to. We also handled this measures as discrete rather than sort of proportional values as well. Some of the transformers that work with measures, you have a choice on whether they're, the discrete values or yeah, like I said, measures that kind of, exist along a line. So there is that as well.
Yeah, I think one thing in the GIST world is very important to maintain monotonicity of measure. So with your really open kind of way of assigning measures, I hope there's some check built in that can ensure the measure, just like in any dimensional axes, is always increase or decrease. There's no repetition of any single measure along this measure line. So that would be something I hope in the future that can be added to it.
Yeah, that's interesting because, yeah, we kind of work the other way in that we don't presume to criticize the data, if you will, in that way, because we know that X and Y values and Z values, to be topologically clean, they should not repeat. But when it comes to measures, some people, if they're using discrete measures rather than like, what do you call it, monotonic measures? So measures might be used for, values that are not really measures, if you will, as far as measuring along a line. So yeah, we don't automatically assume that two measures in a row that are the same are bad. But it would be interesting, yeah, to have a sort of a validation, measure validation tool. That would be.
Hey, Dave, I see some questions here in the chat. Do you want me to read those out loud for everyone? You can answer them, or do you want to just address them?
Oh, sure. I'm sorry, I don't have the chat up.
Yeah, I'll go ahead and read them. So our first question from Quentin says, here lines were created from scratch, but if a user has CAD input data, for instance, polylines from AutoCAD or MicroStation, have you tried to create a workflow to export a report in Excel or CSV format, for example, line length, listing of intersection points, etc.?
Yeah, we could do that. That's definitely possible, with or without measures. Yeah, I mean, we can generate if the intersections are not yet generated, if the data is not clean, we can use a intersector to generate that information, and then again we can we'll have the new points. My favorite. Oh, I am going to show the topology builder. My favorite transformer. You can actually bring all that information in. It'll do the intersections, and then it will give you out an edge node topology from that information. So you can get the nodes and the edges. And as a cool thing is that if you turn on the list accumulation, that the nodes will have a list of all their edges attached to them, the direction of those edges, and the attributes of those edges. So you get on your nodes, and from there you can start doing edge node topology analysis on your data to find out all sorts of things. That's why the topology builder, you run a simple topology through there, and all of a sudden you've generated so much more information. So the nodes know what edges they're attached to, where the edges are going, and what attributes are on the edges. The edges know what nodes are attached to them, the node numbers. Any existing node numbers that come in, or edge numbers that come in, are retained. If not, new node numbers are created. So yeah, from there you can get a lot of analysis done.
Hey Dave, I know that your favorite transformer is Topology Builder, and this is where Topology Builder comes in play. But I can tell you, Topology Builder is one of the most powerful, but also most difficult to understand, as well as two-edged saw. So, but it's so powerful. In fact, if anyone, I think there's one FME hub transformer called LRS ref generation. It uses extensively using Topology Builder to identify the route-to-route intercepting points. And so essentially, I see what you're saying in this case is just doing that type of operation, then export selected attributes, it seemed to me, right?
Yeah, yeah. We actually have a lot of specialized LRS hub transformers. Some made by me. I think you made a couple, didn't you, Bo? And some made by other folks as well that that can do extra things. And yeah, they're all just built on these existing transformers. But yeah, when it comes to, I do a lot of work with topology. So yeah, the Topology Builder, and actually the other one is the Neighbor Finder. With these two transformers, you can do almost anything related to topology. You know, especially when it comes to relating, especially working with CAD data, and you're trying to clean up the CAD data, you're trying to build a workable topology out of the CAD data, you're trying to query the CAD data for information that's just, you know, easy to get in a GIS, but the CAD really needs some prep first. With Neighbor Finder, you can relate points to lines or points to other points by a number of factors, and that's the nice thing. Like the line on or the point on line overlayer is nice, and it does just a simple proximity test, and it gives you some good information. But the Neighbor Finder, you can ask for a list of your nearest neighbors. So I think I'm trying to think when did it. I did it when I was taking labels on CAD lines, right? So first of all, we take the label, we look for the closest CAD line that fits the label, and we find it. But if you're near a corner or anything, maybe that's not the line the label actually attaches to. So then we can look at the angle of the of that line, and we can also look at the angle of the label, and we can say sort out from the list of, say, the nearest 10 matches, the ones that don't go the same way. Say the label's got is 90 degrees opposed to the line, then obviously it's not labeling that line, even though that line's the closest. So you can dive and do a much more complex analysis based on the results you get from that. So these are kind of what we call, in a way, anchor transformers. So you throw down your Topology Builder, you throw down your Neighbor Finder, but then you'd have a whole bunch of these other transformers to actually analyze the information provided by these transformers.
Hey Dave, real quickly, I did not find Neighbor Finder to be measure aware because it does not generate the point, the snapping. Let's say point, find a line, it will get the exact point on line together with measure.
Yeah, it doesn't do the measures. The only way it does measures now is if oh, here we've got measures, place measures Z with candidate. So
okay.
And I think you may need to already have measures on there, but that's something that's been added actually fairly recently. So
Okay, I see.
Last few years anyway.
I'm really glad you showed the Topology Builder. I was really hoping you would.
Yeah, sorry, it didn't really come up in this sort of LRS stuff. Another thing, there is a transformer I called the this is another LRS transformer, the straight. If I could spell right, a straight line diagrammer. It's a big one. It was created to create straight line diagrams, and I haven't updated it in a few years. But the neat thing about it is, if you edit it, it's kind of got all of the techniques I showed you today built in. So it's kind of like a one-stop shop for LRS manipulation techniques, using transformers that, using logic that may be a few years out of date, because like I said, I haven't updated it with some of the new capabilities of the transformers. But yeah, it's just kind of a smorgasbord, because I had to do everything. I had to, trade segments to LRS and LRS to segments, a bunch of other stuff that goes on in there. So like I said, it is kind of a one-stop shop.
I think that's an awesome resource and a good point for people is a lot of these FME hub transformers have workflows that we're all trying to accomplish that have already been baked into a custom transformer that we can either use or look at to experiment with our own data and change for our own purposes.
Yeah, and if you find any issues with the hub transformers, if you go to the help on the hub, so if I go here, no, it just comes up with the help. But if you go to FME hub and let's see, bring up oh, well, here's one of those. So there's a comment section. So if you find any issues with it, or if you want any updates or anything or any improvements, enhancements, you can throw a comment in here, and it would go back to the producer of that custom transformer, which usually is not safe. That's a way of you communicating or giving feedback.
Awesome. We're approaching the end of our time here. We have a couple more questions. I'm going to go ahead and read these out if you're okay with that.
Sure.
The next question from Kevin Hunt is, are there considerations around having the latest measure-aware FME transformers if you're using the data interoperability extension, i.e. do you need to use the latest ArcGIS version of Pro?
Yes, because interop is updated with the Pro on the Pro release schedule. So the latest, I mean, there is a lag time just because our release dates and Esri's release dates don't coincide. So what you're usually getting in interop is the previous year's release, maybe with, it would be a late maintenance release, but it's still the last year's release in the interop. So I think 2.8, did it just come out or is it coming out soon? 2.8 would have, its interop, I think would be equivalent to FME 2021.
Gotcha. Yeah, I do believe it just was released. I think my coworker Carol sent me some information regarding that.
Yeah, so 2021.0 has been out for quite a bit. 2021.1 is not, it's only in beta yet. So you'd be getting a late 2020.0 on that. But that said, all of the, I mean, interop is generally almost a full FME now. I mean, there are some readers and writers that aren't included just because of licensing agreements. So for example, you don't get the sort of the real DWG AutoCAD reader, you only get the ODA one because, Autodesk, our licensing agreements just don't allow us to put an Autodesk library into an Esri product. So, and the same thing with some of the map info stuff. But other than that, I mean, capability transformer wise, it's, for the most part, I think it's completely up to date. And workspaces are now also interoperable between the interoperability extension and FME. So you create a workspace in FME and open it up in the interoperability extension. It will just open up. So we're storing them as FMX files. We're not storing, previously the interop stuff was stored in a toolbox. We're not storing them in toolboxes anymore. You can put them in a toolbox if you really want the pain, but you don't have to. So.
Awesome, thank you. Our next question comes from Doris Jin, and the question is, I have built the dynamic segmentation with FME that clones GeoMedia. One issue I ran into is the line combiner that FME start and endpoint is random, it's a loop.
Ah, yeah. Yeah, I guess a way around that is there's also the path builder. So the path builder is another way of building paths as well as the line combiner. The line combiner basically, it does the extra work of looking at the geometry and figuring out what lines actually touch each other. And so it does that whole analysis. So it's pretty much ignoring feature order. The path builder works strictly on feature order. So you can create a path. So say if you have from your GeoMedia, you have a root ID, and you also have a counter on this, a segment counter. You can use a sorter to sort by on the segment counter, lowest to highest, run it through the path builder, and then group by your root ID, and then it will just build that path in that particular order. It does none of the analysis that the line combiner does. So it actually runs faster, and it's more, if you have the information to control it, you can then have much more control over your order.
Okay, thank you. I'll give that a try.
Sure. And if you run into any issues with any of this stuff, please feel free to drop us our support a line. We're always happy to help out.
Sounds good. Thank you.
Our next question is, are you going to share the workbench at the end?
Yeah, I will revert back to its tidier incarnation, and then I can, yeah, I'll share it with Bo, and then Bo can share it with you guys.
Sure, that works. Okay, and then we also have another question from Carol Francis that says, I've had very little to no success using Esri's interoperability extension. Would it be possible to build a workspace in FME and export it into an Esri-friendly format that would open in the interoperability extension?
Yes, the way to do that is to try to use a not too current version of FME. You can download other versions of FME from our download site. There's a historical or archived section there. And the same license will work with both. Installed into a separate folder. You can have multiple FMEs running side by side. I believe I've got 13 of them running on my VM here, all side by side, different versions, and they all use the same license file. So that's cool. So yeah, if you're say talking to 2.7, if you got ArcGIS Pro 2.7, I would probably back up to 2020.0 for the FME version, the Workbench version. And then as long as you stay away from, like I said, some of the formats that are proprietary, you should be okay. I mean, really, if you can get your Workbench to run in Linux, it'll absolutely work in interoperability. Because I think we lose some of the formats in Linux as well, just because of lack of libraries. And that's all proprietary stuff. Any of the libraries that we created in-house are cross-platform, but not all of the people who supply us libraries are cross-platform. But interop, I mean, interoperability in at least 2.7 Pro, which is what I'm playing with now, I mean, it's a dead ringer for FME Workbench as far as it goes. Has all the same tools and everything. Just like I said, lacking a few of the formats.
Gotcha. Carol, did that answer your question?
Yeah, it sure did. Now my wheels are spinning and I'm thinking about how we can, well, our biggest client is kind of intimidated by FME. And when we build them workspaces, they call it a black box that they don't know how to dive into and troubleshoot and understand how it works. And I'm just thinking that if we put it into a format that they're more familiar or comfortable with, it might allow for better collaboration. So that's interesting. It never occurred to me that interoperability would even talk to FME like this. So yeah, thank you.
Yeah, in I think 2.6, and I'm not sure about 2.6 is the earliest I've worked with, but 2.6 I think and up it's fully interoperable.
Wonderful, thank you.
And the other thing is for clients is you can use. I mean, this is where this sort of stuff, annotations, bookmarks. I mean, I do it
Absolutely, yeah.
This sort of thing, but to quite frankly, if I've got a big workspace, I do these things so I can remember what I did in 6 months.
Yeah, if you look at the video that we published a month ago from our last FME presentation, you see a workspace I did, and there's annotations and bookmarks everywhere. Otherwise, I'd be lost in my own workspace. Yeah.
The other cool thing you can do, although I still have a few issues with the way it expands again, is you can now collapse bookmarks. So. And then you can actually rename the inputs and outputs so the bookmark actually becomes in a little ways a transformer. So what you could do is collapse all the sections that you want your client to never play with at all, and just leave open the section that they can manipulate. And that might be helpful, and it cuts down on the complexity that they see.
Yeah, that's a great point. Thank you.
You're welcome.
Yeah, I love the ability to collapse those bookmarks, but I think you kind of hit the nail on the head and you said you have an issue with how they expand again, especially when you have your workspace all nice and tidy with these collapsed, and then you expand one and it shifts everything in a totally unexpected fashion. And then when you recollapse it, it doesn't shift it back, which I always thought would be really, really nice if you could expand it and collapse it back and have it go back to exactly where it was.
Yeah, it works better with those people who are happy with happier with a messier workspace. I'm a little OCD about my workspaces, so yeah, it's just not quite right. You know what I mean?
Absolutely.
So, but some people are much more flexible with their workspace appearances. So it works for everybody, I suppose.
I don't see any more questions in the chat. Bo, did you have a question?
Yeah. And I think this one is regarding, I noticed you used feature merger, and we use recently extensively using, you use a feature merger. Yeah, we use feature joiner nowadays more and more. Could you elaborate on the two transformers, and which one that in what scenario would you use feature merger versus feature joiner?
Yeah, I haven't been playing with the feature joiner too much. The feature joiner has in a way, less capabilities than the feature merger when it comes to the way it joins. But on the plus side, it works really well with feature tables. And this is something we've been working on over the last couple of years, is that traditionally FME worked on a feature by feature basis. So each single feature had all this header information, which includes the sort of schema and everything attached to it. And there was a lot of overhead with processing all that, feature by feature. And then what we've been recently looking at is that a lot of our data is database and stuff from database or is at least fixed schema. And instead of having each individual feature with all this information, why don't we just have a table of features with the header of the table containing all the common information, and each record in the table just containing the unique information. And we did this, and this is actually based a little bit off of our point cloud work. So we have these things called feature tables, and a feature table, and essentially it's just a point cloud without geometry. And because the overhead of the data is so much less, we could get a much greater performance out of a lot of our transformers if they could keep these things as feature tables. And so the feature joiner creates feature tables. It works on things as a table basis. Feature merger is individual features go through, and it's a check. Whereas a feature joiner is doing sort of a table join. So we're using database engine tools to do these joins, and it is much quicker. And in a way, it's also a little bit more understandable to somebody from the database and SQL world, right? We've got left and right instead of supplier and requesters. So somebody who's used to SQL can jump right in here, and then your join mode, inner, left, full join. So from a SQL database type person, I think it's more understandable, and it's also much quicker. And the output of a feature joiner is a feature table. So now feature tables do have a few issues for hackers like me, in that they mess with the order of the features. So if your workspace is order dependent, you can have issues there. But generally, it's the important performance improvement is really worth it.
Yeah, the other thing was the thing I like about feature joiner certainly is the performance, easy to understand and use. But there's also one limitation. It only joins on equal values. It does not, like in a SQL, where clause, where you can have the comparison of something larger than or smaller than that. I'm hoping that in the future that can be expanded to a more like a typical SQL where clause type of query as much as possible.
Yeah.
And the other thing, I think the feature joiner does not generate any additional, let's say, list processing. I think feature merge or others might have, because the feature base, it can generate, the lists as it processes. I guess.
Yeah, the cardinality, I think, is pretty much 1-to-1, isn't it? So, yeah. Whereas to list, you want a 1-to-many. For those who want to get more into the SQL weeds, or if you're more familiar with SQL, we have the inline querier.
Yeah.
And this is essentially, it's a SQL engine within FME. So it's one of the more complex transformers to use, but essentially allows you to run SQL queries on your FME data. And I think we're implementing it as a SQLite under the hood. So you're looking for SQLite variants of SQL, and you can actually here create quite complex SQL queries based on the data. The thing to remember about the inline querier is that our inputs, where you set up the table and the columns of the inputs, all the information in the inline querier is solved. So for the columns, you only pick the columns that are going to be in your SQL. And this cuts down on the duplication of the data and makes it run much more quicker. But yeah, you can really go to town here.
Yeah, I think the SQL capabilities inside of FME, including the SQL executor and the inline querier and all that, are so powerful. There's no way we could dive into anything relating to how awesome they are in this presentation. I think we should reserve that for a future meeting for sure, and kind of show some of those capabilities. I don't see any other questions here. Does anyone else have any questions? You can feel free to unmute and ask, or type it in here. And if not, I think we'll go ahead and start wrapping up the meeting. All right. Sounds like no one's got any questions for you, Dave. I'm going to go ahead and take the presenter role back, and then we'll go ahead and wrap this up. All right. Hopefully you guys can see my little wrap up slide here. So really, first off, just a huge thank you to Dave and Safe for giving this presentation and educating all of us on some of these more complex topics for the LRS system. I think everything he showed is incredibly relevant to all of our day-to-day work, and really benefits everyone involved. If you have any questions, I put Dave's email out there. I think you can reach out to him. In terms of the transformer and the recording of this, I will post a link to both of those inside of this FME transportation SIG, as well as inside the actual event. So once we have that uploaded to YouTube and the workspace from Dave, we'll go ahead and post all that up there. So please don't email Dave 20 emails asking for the workspace. We will go ahead and get that to you. But if you have any other FME specific things, I think that Dave would be that point of contact. Our next presentation is going to be next month. Again, they're on the third Wednesday of every month at noon Central Time. So that falls on, forgot to change the date there. Sorry, it's going to be on the 16th of next month, I believe is actually the date there. Not the 19th, that's today's date. And then again, if you guys have any questions, comments, or looking to present, go ahead and email me at that email there, and we can go ahead and get you scheduled. We do have a handful of people already interested. We're just trying to resolve what dates and times are available, since not everyone can present at this time frame. So again, yeah, if you have any questions or want to present, go ahead and reach out to me. And lastly, yeah, just a big thank you to everyone who showed up. And I see one more chat. Let me see what's in there. Oh yeah, absolutely, Dave, or absolutely, Kevin. Thanks for showing up and attending. Yeah, that's all I have for you guys, and we'll see you next month.
Thank you.